How you doing? Thank you. Okay. Sorry, please. My network is just too slow, but I'm connecting to something. We'll soon start now. 1 minute. It's going to be a very interesting class because we're going to be covering very, very important things which are commonplace in your JAMB. So who can remind me of the year we worked on last? Which was the last year we worked on? I hope we can still get my volume. In the past question, which was the last year we worked on? Tika, can you remind us of the last year we worked on?
I didn't join the class. It was 2018. So can you hear me?
No, I'm hearing you now. Say, I can hear you now. Say something again.
When I stopped was 2018.
Okay, you did 2018, but you did not do 2020. 2020 was the last one we looked at. Are you clear on that?
Yes, sir.
So today we're going to be looking at 2018. 2018 is the assignment for this week. So please, everybody, make sure you are attempting the past question. Make sure you are attempting them. The past questions are very important to our learning. And like I said, if you are supposed to make 220 or 250 before, because of the extra 2 weeks extension, you're supposed to be able to make up to 300. And how can you be able to make 300? The only way you can do that is by working on the past questions. And we're looking at the 5-year past questions. So make sure you're working on them. They are very, very important. Okay. 5-year past questions. Okay, so this is the platform we are working with, educateafricans.com. So we are expected to have registered and we're here. Okay, so I'm going to quickly open up what we have for today. So today we're going to look at representation of images formed on curved mirrors. Then once we are done with that, we are going to look at transformers. So those are the 2 major things we'll be looking at today. Representation of images on curved mirrors. And we're going to also be looking at transformers. Choma, I don't know whether you heard what I just said now. Choma, can you hear me?
Yes, I heard you.
Okay. So the network is seeming to be slow on my side. So I wanted to make sure you heard. So I'm going to quickly go down to physics. Okay, so we have physics opened. Then we're going to scroll down. So we just updated this now. So I have transformer, gravitational field, and mirrors. So let's look at these three things. So we're going to be looking at them with a past question. So we'll be able to appreciate how the question will come. Okay. Okay. Choma, can you see my screen?
Yes, I can.
Chika, can you see my screen?
Yes, I can.
Oluwaseyi, can you see my screen? Blessing, can you see my screen?
Yes, sir.
Okay, so let's start. From this very problem, you're going to understand more about transformer. You're going to understand about the primary and secondary coil. And you're going to understand what a step-up transformer is and what a step-down. It's a simple question, but this is typical of how we handle our problems in Tclassified or in Educate Africans. Once you have a simple, very simple problem, with that, we explain a whole lot of things surrounding that very problem so that you understand it much better. Okay, so let's start now. So the question says, the primary of a transformer has 100 tons. The primary has 100 tons. And its secondary has 200 tons. So you see, the primary has 100 tons. So whenever you talk about primary, you talk about the coil on the left-hand side. That's the primary. It has 100. And the one on the secondary is normally the one on the right-hand side. And that one is 200. So if you have a smaller primary and a bigger secondary, that means you're having what we call step-up transformer, because you're stepping from this small 100 and going to 200, which is bigger. So this is a step-up transformer. But if you have your primary to be big like this, and you have your secondary to be now small, this is what we call a step-down transformer, because it's moving from the bigger tons of coil to a smaller tons of coil. So this is step-down transformer, step-down. This is step-up transformer, step-down transformer. So Chika, can you tell us the difference between a step-up transformer and a step-down transformer from what I just explained?
In a step-down transformer, the primary has more coils than the secondary. But in a step-up, the primary has smaller coils than the secondary.
Perfect, 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 perfect. Choma, which side of the coil, which side do you get the primary and which side do you get the secondary? Sharp, sharp. So if I ask you questions, sharp, sharp, so that we can move on to other things. I don't want delays. Choma, are you there? Okay, Johnson, which side do we have the primary and which side do we have the secondary?
So, is it in the diagram?
Everything I'm asking you is already on the diagram. So you look at the diagram and explain to us.
Like, okay. From the first diagram, we are having the primary coil from the left-hand side and secondary on the right-hand side. And in the second diagram, we are having the primary coil in the left-hand side and the secondary coil in the right-hand side.
Yes. So like I said, the primary is always on this very side, this left, and the secondary is always on this right. You can see how I wrote it, how it is written. This is EP, meaning primary voltage. This is ES, secondary voltage. And secondary voltage is supplied by the secondary coil. Primary voltage can supply by this primary coil. So primary is always on this side, whereas secondary is on this side. So whenever you find out that that primary on this side is bigger, and the secondary is smaller, we'll call it step down because it's going down from big to small. But when we find out that it's small, whereas this side is bigger, then it's step up. I hope that is clear. So
Yes, sir.
who can
Yes,
tell
sir.
me now the type of transformer we are having from this question that is asked, that the primary has 100 tons, whereas the secondary has 200 tons. Chika, can you tell us the type of transformer that we're having there?
Step up transformer and step down transformer.
Who's saying step up and step down? How can you be having step up and step down? Who can
Step
tell
up
us?
is step up transformer.
Who is the person that says step down transformer?
Step up transformer.
Listen.
Sir?
Why you
I
asking
said
other things? You're confusing us.
So I said step up transformer.
Good. So this is a step up because the primary is having 100 and the secondary is having 200. Okay. So now we've understood what the points of a transformer where they are located is. So let's move on now. Determine the voltage on the secondary. And we want to put your mic on mute to Johnson Ojo. You're disturbing our class. Why the boy cannot hear something? Okay. So having understood what a step up, a step down, primary, secondary coil is, now I also told us that the primary coil is what produces the primary voltage. You can see it, this primary EMF, which is primary voltage. And here we have secondary coil producing the secondary voltage. That's what we know. Now we have a relationship. So this is a typical step-up transformer because it's going from little coil to bigger coil or little voltage to bigger voltage. And this is a typical primary transformer because it's going from a bigger coil to a lower coil. Now, let's now learn the relationship between the EMF, the number of turns, and the current. So what is the relationship between the number of turns and the current? So that's the next thing we are supposed to learn. Or the relationship between the voltage and the number of turns. So like I said before, a bigger voltage gives a bigger current. I mean, a bigger coil is given by a bigger voltage. So voltage and the number of turns, which is the coil, they are directly proportional. That's why you have voltage of secondary giving voltage of secondary, whereas voltage of primary giving voltage of primary. But the reverse is the case for current. They are inversely proportional to the current. So for the current of primary all over the current of secondary, as against how it is arranged for this and this. But now the relationship we are looking for is the relationship between EMF and number of turns. That is voltage and number of turns and not current. So forget about this very relation. So we'll look at this very one now. So how do we relate this? We are given this one. We are given this one. We are given the primary voltage but we need the secondary voltage. We are given the number of turns here, number of turns. So Chika, what's the number of turns for the secondary?
$200.
200, good. Blessing, what's the number of turns for the primary?
100.
100. Johnson, what's the voltage for the primary?
100.
So making ES, which is the secondary voltage, the subject, which is what we are supposed to do. So ES becomes 100 times 200 over 100, which is 200 volts. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
It's very clever.
Yes, sir.
Okay, so this
Yes,
is
sir.
the relationship. ES over EP equal to NS over NP equal to IP over IS. So it's only here that it's changed. Yeah, the secondary is always up, but for current is the primary that is up. So you have to find a way of memorizing this very formula. And this is the formula for your transformer calculations. Are we clear on this?
Yes, sir.
Yes, sir.
Okay, so we've understood how to do transformer calculations very, very well. What if we are given current? You know that we are supposed to. So you can use only these two equations together. You can use this one together. You can also use this E's against P's together. So make sure you can, this is equal to this and equal to this. So you can use only these two together. You can use these two together. You can use this one and this one together. Are we clear on this?
Yes, sir.
So you simply make the right one the subject of the formula and you're good to go. So can we move to the next thing we have for today?
Yes, sir.
Yes,
Okay,
sir.
so I said we are covering 3 topics. How many topics are we covering?
3 topics.
So 3 topics. So we've done transformer. The next one is gravitational field. That's the next thing. So in solving this problem, we are using problem solving approach because, like we said, we are approaching our exams. So we don't want to go and be opening and be teaching you plenty things that might not be required. So we'll solve a problem. Then from the problem, you can easily relate and understand the concept. Any other question that you have will revolve around what we'll solve. Are we clear on this? Okay,
Yes,
so let's look at this one. This is under gravitational pull. Now, I want to, before I start everyone, I will always explain the concept. Is anybody seeing what I have on my hand?
Yes, sir. We can
Yes,
see
sir. Yes, sir.
What is it?
Newton's law of
I mean what I have on my hand. I don't mean what.
gravitational. Newton's law. Oh, stapler.
Stapler, thank you. Who can see the next thing I have on the other hand?
Go down.
Key.
Key, thank you. Johnson, put your mic on the mute. Now, what we are learning now is the law of gravitation proposed by Newton. They call it the Newton law of universal gravitation. And it states that every particle in the universe attracts every other particle. So that means that this very stapler is always attracting the other one, known as key. And it does it with a force that is proportional to their masses. So if the force of this, if the mass of this stapler is so heavy, and the mass of this key is so heavy, in fact, you will be feeling that attraction. You are not actually feeling it because they are not as heavy. Who can tell me a situation where you can feel an attraction? Can anybody tell me a situation where you can feel such an attraction of gravity? You said
Through magnets.
Chika said through. Oh yeah, Chika, put your mic on mute. Let me talk now. So Chika said through magnets that you can notice it. You can actually notice a magnet, but what is getting them together is not the force of gravity. What is getting them together is the magnetic force. So I want somebody to give me an instance where you have something attracting something, but it's not a magnet. In this case, it's a gravitation force. making something to come. Who can give us the example? Can anybody help us?
Sir,
Yeah, Choma, I can hear you.
let me try.
Yeah, try.
Like when a stone is being thrown on the air, it's the force of gravitation that brings it down.
Perfect, perfect, perfect. That's a perfect example. Once you lift something up at any distance, the force of gravity of the earth, because the mass of the earth is so big, it would attract it down immediately. So it's not as if that thing is just falling. It's actually being attracted due to the gravitational force of the earth. And you're able to feel that one because the mass of the earth is so big. But when I place these two things here, you cannot feel the magnet because their masses are very small. Because their masses are very what? Class, their masses are very what?
Small.
Small.
Good, they are small. But that doesn't mean that there is no force of attraction. So a very good example of where we notice this is when something is placed as a knight or you throw something up. As you're throwing it, the force of attraction, which is gravitational force of the earth on that, the earth is exerting on that very object, it will make it to go down. So that is what Newton was talking about. So always believe that there is a force of attraction, but you feel it more, like I said, when the mass is so much, because it's dependent on the mass, which you are going to see now. So Newton's law of gravitation, of universal gravitation, states that every particle in the universe, they attract every other particle with a force that is proportional to their masses. So the force is proportional to their masses when you multiply them, and inversely proportional to the square of the distance between them. So you can see in this equation that is what is represented. The force attracting these two very masses is directly proportional to the product of their masses and inversely proportional to the square root of the distance that is separating them. Are we clear on this law? Check, are we clear on this law?
Yes.
Is this, Choma, the law, is it very clear?
Yes, sir.
Blessing, is the law very clear? Okay, so you're going to be asking JAMB to state which of the following is the Newton's law of gravitation. So you should be able to state it. Now the force acts along the line joining the center of the two particles. So if you have a body here and you have another one here, the force acts on the line joining the two of them. So take note. So this is the mathematical representation of the Newton's law, as you can see. Then we always know that whenever we want to change proportionality sign to equal to sign, what do we introduce? Who can tell me what we introduce whenever we want to change? We introduce a constant, okay? And that constant here is G. That's why we're able to change this very sign to an equal to sign. So this formula becomes this. So now let's solve this very problem. It says, so the question says, two objects, P and Q. So in this case, the mass of P is M1, the mass of Q is M2. So they are having masses 100 kg and 20 kg respectively. And they are 1.2 meters apart on a horizontal surface. Calculate the net gravitational force acting along Q. Now, given that G is equal to, that's the universal gravitational constant, is equal to 6.67 times 10 to the power minus 11 Newton meter square per kg square. So calculate that. You can see that it's very simple. So what you simply do is that you come to this very equation and you substitute. So when you substitute, you get your answer. Everything is given. Choma, is this clear?
Yes, sir.
Chika, is it clear?
Yes, sir.
Blessing, is it clear?
Yes, sir.
Johnson, Ojo, is it clear?
Yes, sir.
Adekoya Oluwaseyi, is it clear? Adekoya, what's your second name? I didn't see it well. Can you hear me? You have to unmute yourself if you want to talk, because we are not hearing you. Can't hear you. Okay, so let's move forward. So just like we've covered everything there, you see that the question asked here is just this, the simple calculation we did last. But before we started it, we were able to explain what the Newton's law of gravitation stated, so that you understand the statement. And you also have to know that the force acts along the line joining the two centers. So they might ask you, which of the following is not correct about the Newton's law of universal gravitation? They will say, 1, the force acts along the line joining the two centers. 2, B, the force is inversely proportional to the square of the distance between the two particles. And C, the force is directly proportional to the product of their masses. Then D, none of the above. So who will say the answer? What's the answer? So from what I explained now, which option is the answer? Is it A, B, C, or D? Who was paying attention? Let me come again with the question.
C.
Okay, D. Yeah, Johnson just said it's D. So D is the answer, because other things are form part of the definition of the universal law. Number 1 is that the forces are acting along the line joining the two centers. The force is inversely proportional to the square root of the distance between the two particles. The force is directly proportional to the product of the masses of the two particles. So take note. So can we move to the next topic? Chika, can we move to the next topic?
Yes, sir.
Okay. So the next and the final topic we are looking at today is the mirror. So let's look at it. Chika, can we see my screen? Blessing, can we see my screen?
Yes, sir.
Yes.
Okay, so let's look at this problem. Okay, it's about to rain in my place. It's about raining. So let me rush so that the network will not go back. To obtain a virtual, erect, and magnified image from a converging lens, an object must be placed at what position? A, between the focus and the lens. B, at the focus. C, between the focus and twice the focal length. D, beyond twice the focal length. So, at which position will you place the object in order to produce an image that is virtual, erect, and magnified? So in order for you to understand this, you need to understand the image is formed on a converging lens at various positioning of the object. So we're going to start from number 1 position. And the number 1 position says, for a converging lens, another word for a converging lens, please take note, another word for converging lens is concave lens. Now the image, if you want to produce an image that is positioned between focus and the center of curvature, and you want that image to be real, you want that image to be inverted, and you want that image to be diminished, you place the object in order to produce such an image. For you to do that, you must place the object after the center of curvature. Can you see this is the center of curvature? This is the object. So this is the center of curvature, which is like the middle of the mirror when you complete the mirror complete. This is focal point, which is just like the middle between the center of curvature and the pole. So once you place the image, you can see this is the image. I mean, you can see this is the, what's it called? This is the object. Once you place the object here, this is the image that is produced. You can see that this image is very small compared to this, so it is diminished. And you can also see that it's pointing towards the ground. That means it is inverted. And you can see that it's formed on this other side, this right-hand side. Anything that is formed on this right-hand side is real. You can see it's real. And you can also see that the image is between what? F and C. So if you want to form such an image, make sure you place the object after or far from the C. Now let's take another instance. Once you want the image to be exactly on the center of curvature C, and you want the image to be real, you can see this image is real. Real image is any image that is formed on this, on the right hand side. And you want the image to be inverted, you can see this image is inverted. And you want the image to be the same size as the object. Where do you place that image? You must place it directly on C, on the center of curvature. So once you place the image on center of curvature, the position of the, once you place the object, I mean, on the center of the curvature, then the position of the image will also be on the center of curvature. And it's going to be inverted. It's not going to be diminished. It's going to be the same size. You can see that both of them are on the same side. Okay, now, when you want your image now to be beyond the C, you want it to be beyond C. So this is C. And you want the image to be after C. You can see this is where the image is. And you want it to be real. That means you want it to be on the right-hand side. You don't want it to be on the other side of the mirror. And you want it to be inverted. You can see the image is pointing downwards. You want it to be inverted. And you also want it to be magnified. Where do you place your object in that case? In that case, you must place your object between C and F. You can see it between C and F. That's where you must place your object. So once you do that, you get this sort of qualities of image. Now, what if you want your image to be at infinity? You want it to be real. And when I say real, formed on this side of the mirror, and you want it to be inverted, you want it to be pointing downwards, and you want it to be greatly magnified. Where do you place? Then you must place your object on the focus, focal point F. Now, lastly, what if you want your image to be behind the mirror? So you don't want it to be real. That means you want it to be virtual image. You want it to be erect, and you want it to be magnified. Where should you place your object? So you can see that this image here now is on the other side of the mirror. This is the curved mirror. This is the curve of the mirror. But the image is only on this case that it is on the other side. And it is erect. It's not inverted. And it is magnified. So where do you place the object to get this kind of image? You need to place the object between the focus and the pole or the lens. So with this now said, who can tell me the answer to the question that we asked? Because the question says, to obtain a virtual, the image has to be virtual, erect, and magnified image from the converging lens. An object must be placed, is it A, between the focus and the lens, B, at the focus, C, between the focus and twice the focal length, D, beyond twice the focal length? Who can tell us the answer?
D.
D. Somebody say D. Is it D? Who said D?
Yes, D.
Huh? Okay, somebody said B. Is it B? This is what we want. Your image, you want your image to be virtual, erect, and magnified. So in which of these cases do we have virtual, erect, and magnified image? In this one, we have what? We have real, inverted, and diminished. Here we have real, inverted, and same size. Here we have real, inverted, and magnified. Here we have real, inverted, and magnified. Here we have virtual, erect, and... Which option? Which option is the right answer?
D.
No, this is a case of A. Between the focus and the lens. because that's exactly the situation we have here between the focus and the lens or the pole. That's the situation that gave us virtual, erect, and magnified. So option A is the answer, between the focus and the lens. So take note of that. Please quickly go to your app and open up this. If you enter your physics, you're going to find out that it is the last one. Light and mirror. This is it. Quickly open it up. And as an assignment, I want you to give me the various conditions for having the various properties of an image. So I want you to draw these things exactly the way they are and submit it to the WhatsApp group. That's your assignment. So draw them and study it. Everybody, draw this. I want this exactly the way it is written. So be in your handwriting and you submit it to the WhatsApp group. So we'll cover like 3 topics today. 3 good topics. So if you're doing it, you will learn more. So make sure you're getting ready for your exams. I hope you guys are giving me 300. Check, are you guys giving me 300? Choma, what score are we? Are you guys assuring me of?
So
by God's grace, good. Choma, what score are you assuring me of?
By the special grace of God, 300 and above.
300 and
Amen.
above. Good. That's what I want from everybody. And it's like JAMB is going to postpone. It's likely. I don't know. They say they are having a meeting today. So if they postpone, instead of giving me 300, I'll be expecting 350 and above. So the more they postpone it, the more I expect more score. And the only way you can get the more score is by solving the past question. It's not by saying I'll get it. These things are not done by just, it's done by work. When you have faith, you want to achieve something, you are praying for it. Make sure you're working hard also. So I'm going to paste here what you have to do.
That Educate Africa, is it an app or a website?
You can go through the website. Some people are complaining that the app doesn't play the videos very well. So just go to your Chrome on your phone or your laptop. Just type Educate Africa as a website. You see it as also a website.
And sign up, is it for free? Sign up.
Yeah, go to the sign up page. Make sure you sign up. If you don't sign up, the videos will not open for you. So make sure you sign up first. Then you try opening again. Then once you sign up, make sure you log in, it will open. So quickly go there, get this thing down. Everybody, once you don't submit it, I'll not be happy seeing you in my class again. So do this and submit, because these convex lens, these lenses, they come out every year. So that's why I don't want you to fail it. And that's why I took our time to draw these things and teach you now. So please take note. Concave are used as shaping mirror.
Are we going to submit it in the group?
Or George Johnson, when I'm talking, just be quiet so that you hear me before you continue talking. Now, Ojo Johnson. Now, concave, if they ask you what type of mirror is used for as a shaving mirror, know that it is the concave mirror, and that's the one we've looked at. Now, the convex mirror is in convex mirror, the image is always smaller, erect and virtual for all these positions. That's why we didn't consider for all the positions. We only consider that of concave, because for convex is always smaller, erect and virtual. Okay, so thank you. God bless you. See you when I see you. Chika, did you understand about what I explained last?
Size concave mirror.
Yeah, I say concave mirror is always used as a shaving mirror. Note that. Whereas the other one is always used as a what? It's always the erect and virtual, and that's why they are used as driving mirror. The convex is used as driving mirror. The mirror that you have in your car, your father's car that is using, is convex. Are we clear on this?
Yes, sir.
Okay, thank you. God bless you. Please make sure you do the assignment. Chika, I'm expecting your assignment immediately. So, Ojo Johnson, Adekoya, please let the assignment be done immediately and submitted immediately so that you'll be ready. So you people should check the WhatsApp group. Let me share the JAMB pass question that I want you guys to work on today. Also work on the JAMB question immediately. Don't be keeping it tight. Don't be giving it to, I will do it tomorrow. once I give you this assignment, do them immediately. That's how you learn. Immediately.